Less than 600 meters from California's last operating nuclear plant, there's a fault line that wasn't discovered until 4 decades after construction began. Diablo Canyon generates 9% of the state's electricity from 2 reactors that have exceeded their 40-year design life. California planned to close it. Then a 2022 energy crisis forced the state to extend operation toward 2030, backed by a $1.4 billion loan, not because the safety questions were answered, but because the grid couldn't afford to lose it. What that compromise is actually risking is a question the country has barely begun to ask. Sited on a rugged coastal terrace near San Luis Obispo, overlooking the Pacific, this Pacific gas and electric facility stands as California's last operating nuclear plant. The complex houses 2 massive Westinghouse pressurized water reactors, designated as Unit 1 and Unit 2, which together supply 2,256 megawatts of capacity, providing approximately 9% of the state's total electricity. Inside these reactors, water is kept under extreme pressure, so it heats up to high temperatures without boiling, transferring its thermal energy through a closed primary loop to a secondary water system that produces the steam to spin the turbine generators. This separation prevents radioactive water from contacting the external environment. PG&E began construction on the coastal site in 1968, pouring thousands of tons of concrete into the headlands. Although the units did not start commercial operation until 1985 and 1986, their initial licenses were limited to 40 years. This 40-year design life served as a regulatory baseline for depreciating the plant's massive capital costs, reflecting mid-century assumptions about technology and economics. It was never intended as an automatic safety threshold or a mechanical expiration date. With both reactors now operating past that original expectation, a baseline question remains. What did the original design record not yet know? When Pacific Gas and Electric broke ground in 1968, regional seismic mapping along the central California coast was incomplete. In 1971, geologists discovered the offshore Hosgri Fault just 3 miles from the site. Rated capable of a magnitude 7.5 earthquake, the discovery forced a massive structural overhaul. Retrofitting the unfinished facility to survive this newly discovered threat sent construction costs soaring from an estimated $320 million to over $5 billion. While magnitude measures the energy an earthquake releases, engineers design for peak ground acceleration, the physical force of the shaking. Diablo Canyon's safe shutdown baseline, originally set at 0.4 G, was retrofitted to withstand 0.75 G of ground acceleration. In 2008, scientists detected the shoreline fault, running less than 600 meters from the water intake structure. A 2011 study evaluated whether a joint rupture along both the Hosgri and shoreline faults could produce shaking beyond the plant's design envelope. While the Nuclear Regulatory Commission concluded the plant's margins remained adequate, Senior Resident Inspector Michael Peck issued a formal non-concurrence in 2013. He argued that the agency had not demonstrated that critical safety systems could withstand the combined ground motion of these closely linked faults, exposing a geological debate that persists today. On March 11, 2011, a magnitude 9.0 earthquake and a massive 15-meter tsunami struck the Fukushima Daiichi plant in Japan, causing 3 reactor meltdowns in the worst nuclear accident since Chernobyl. The disaster prompted a global reassessment of coastal nuclear facilities situated in active seismic zones. However, the mechanical layouts of these facilities vary. Fukushima relied on boiling water reactors, whereas Diablo Canyon operates pressurized water configurations. Yet both designs face the same fundamental vulnerability during a station blackout, where a complete loss of off-site and backup electrical power halts the pumps required to cool the reactor core after emergency shutdown. In the United States, post-Fukushima inspections at Diablo Canyon identified 20 safety and backup power deficiencies. In response, the Nuclear Regulatory Commission mandated rigorous upgrades for flooding resilience and severe, unplanned emergencies. By 2020, PG&E completed these modifications, installing flood-proof enclosures, adding redundant diesel generators, and strengthening the emergency core cooling systems. While the federal regulator verified these safety improvements, critics maintained that the primary threat was left unaddressed. Environmental advocacy groups, including Mothers for Peace, argued that no amount of backup equipment could secure the facility if a major rupture along the closely linked Hosgri and shoreline faults produced ground motion that exceeded the plant's ultimate structural limits. In June 2016, Pacific Gas and Electric announced a plan to shutter both reactors when their federal operating licenses expired in 2024 and 2025. The decision was purely economic. State policy heavily favored rapidly expanding solar and wind resources, which made the high fixed costs of operating a baseload nuclear plant appear increasingly uncompetitive. State regulators approved the closure, viewing it as a milestone in California's transition to renewable power. But by 2022, a changing climate disrupted those calculations. Record-breaking summer heat waves drove electricity demand to historic heights, while severe droughts crippled the state's hydroelectric generation. Facing the immediate threat of widespread rolling blackouts, Governor Gavin Newsom and state lawmakers executed a dramatic policy turnaround. In September 2022, Newsom signed Senate Bill 846, authorizing Diablo Canyon to continue operating for up to 5 additional years, pushing the retirement targets to 2029 and 2030. To fund the necessary operations, the state approved a loan of $1.4 billion to PG&E. This emergency intervention prioritized grid reliability, serving as a calculated stopgap to preserve the power supply. It established the state's political approval for extended operations, shifting the ultimate decision to federal regulators who would have to determine if the aging facility was physically safe to run. Federal law, specifically Title 10 of the Code of Federal Regulations, Part 54, dictates whether Diablo Canyon can operate past its original limit. This federal path is entirely separate from state-level authorizations. On November 7, 2023, Pacific Gas and Electric submitted an application to the Nuclear Regulatory Commission, requesting a full 20-year license renewal. This request sought to extend operations until 2044 for Unit 1 and 2045 for Unit 2, a timeline far exceeding the state's 5-year reliability window. The review process mandates a rigorous aging management evaluation. Engineers must prove that safety-related structures, containment systems, and electrical circuits can withstand decades of continued exposure to heat, radiation, and salt air. This technical assessment is accompanied by an environmental review, public comment periods, and potential hearings. On April 2, 2026, the Nuclear Regulatory Commission approved the 20-year extensions, granting the federal right to operate into the mid-2040s, though California's state-level restriction to 2030 remains in force. Safety advocates and independent scientists warn that the federal review treats components in isolation. They argue that aging plants face compounded risks, where minor degradations in separate systems, such as localized concrete spalling combined with electrical cable fatigue, can interact in unpredictable ways that a standard, component-by-component review fails to identify. Across the United States, Diablo Canyon is far from an isolated case. Data from the Nuclear Regulatory Commission shows that as of late 2026, 93 of the 94 operating commercial reactors in the country have received or applied for license extensions, pushing a fleet with an average age of over 40 years well past its original design life. These plants were constructed under mid-century engineering assumptions, before the long-term physical toll of decades of continuous heat, pressure, and radiation was fully mapped. At the core of the technical challenge is the reactor pressure vessel. This massive steel container holds the nuclear fuel and faces a constant bombardment of high-energy neutrons. Over decades, this exposure causes neutron embrittlement, a process where the steel loses its ductility and becomes brittle, increasing the risk of fracturing under sudden temperature changes. Because these vessels are highly irradiated and structurally integrated into the containment foundations, they cannot realistically be replaced. Other critical components, while replaceable, require constant surveillance and maintenance. Steam generator tubes suffer from stress corrosion cracking and physical wear. Thousands of miles of electrical cabling experience polymer insulation degradation from heat and moisture, while structural concrete structures undergo localized cracking and deterioration. Managing these overlapping degradation mechanisms is the baseline reality of operating an aging nuclear fleet, transforming plants designed for a 40-year lifespan into experimental arenas of long-term materials science. While physical steel and concrete degrade, the human infrastructure of the nuclear industry faces an equally steep trajectory. Diablo Canyon relies on a workforce of approximately 1,200 operations personnel, yet the sector faces a widening national labor shortage. Many of the engineers and operators who built the facility and mastered its idiosyncratic systems are reaching retirement age. This transition risks a loss of plant-specific institutional knowledge, the unwritten operational histories, subtle equipment behaviors, and unusual failure modes of a plant constructed in the late 20th century. Operator license expirations have steadily climbed since 2020, complicating essential knowledge transfer efforts. Modern nuclear engineering graduates are trained on advanced digital designs, creating a practical mismatch when operating Diablo Canyon's older, analog control room setups. This knowledge gap is further strained by regulatory realities in federal oversight. According to a 2023 Government Accountability Office report, the Nuclear Regulatory Commission has faced a 20% budget reduction, directly impacting its inspection capacity and oversight staff. Critics argue that this combination of an aging workforce and reduced regulatory resources creates a compounding risk, where subtle operational errors are more likely to go undetected. This human element remains essential, raising a fundamental question: who will maintain the safety of this massive coastal footprint once electricity generation eventually stops? Since Unit 1 achieved first criticality in 1985, Diablo Canyon has generated approximately 2,100 highly radioactive spent fuel assemblies. Every single metric ton of this high-level waste remains on the coastal site. Initially, the fuel went into steel-lined concrete pools filled with water to absorb the intense thermal heat and radiation. But these pools were never designed for permanent disposal, and as they neared their limit of 2,200 assemblies, the utility began transferring the older, cooler fuel into heavy steel and concrete dry casks situated on a concrete pad overlooking the ocean. This temporary on-site arrangement has effectively become a permanent reality. In 1982, Congress tasked the Department of Energy with building a national underground repository, but the chosen site at Yucca Mountain, Nevada, was halted in 2010 due to political opposition. With no replacement site approved, the federal government has failed to provide a disposal pathway. As a result, Pacific Gas and Electric and the state of California must act as indefinite custodians of this material. Whether the plant's turbines finally stop spinning in 2025 or 2030, the radioactive legacy of Diablo Canyon is anchored to this seismically active coastline for generations to come. The case for keeping Diablo Canyon online rests on a fundamental distinction in power generation: the difference between variable energy and firm capacity. Wind turbines and solar panels generate electricity only when weather conditions and daylight permit. When the sun sets or wind speeds drop, the grid requires immediate, reliable power from resources that can be dispatched at will. While battery storage in California has expanded, storing power for hours is not the same as generating continuous large-scale electricity. This gap between peak renewable production and actual demand creates periods of vulnerability, especially during late afternoon heat waves. According to modeling from the California Public Utilities Commission, suddenly removing a major firm generator like Diablo Canyon would force the grid to rely heavily on fossil fuels to maintain reliability. Their projections indicate that replacing this capacity with natural gas peaker plants would increase the state's carbon dioxide emissions by approximately 2.5 million metric tons annually. A study from the Energy Institute at Haas supported this warning, calculating that extending the plant's operation reduces the probability of a grid reliability shortfall from 12% down to 4% during extreme weather events. This grid-level calculation reveals a difficult climate paradox. Shutting down the reactors early to eliminate localized geological and waste risks would likely lead to higher greenhouse gas emissions, directly undermining California's statutory clean energy targets. Renewable energy and batteries are growing rapidly, but they do not yet operate as a direct, hour-for-hour replacement for a continuous baseload facility. California is not alone in this struggle. Across the United States, 20 states are actively evaluating nuclear license extensions or new reactor construction as a key mechanism to meet decarbonization goals while maintaining grid stability. Policymakers nationwide are confronting the same unresolved equation, balancing the immediate physical risks of operating aging nuclear infrastructure against the long-term climate and economic consequences of losing massive sources of carbon-free power. The debate over Diablo Canyon exposes a deep tension between political necessity and physical reality. California's decision to extend operations was a policy maneuver to avert immediate blackouts during an energy crisis. It was not an engineering determination that structural safety margins had improved with age. As the facility operates beyond its original design envelope on an active fault line, hosting decades of high-level waste with no permanent home, it represents a calculated compromise replicated across the national nuclear fleet. These aging reactors are entering operating realms their original designers never fully anticipated. This leaves the country with an uncomfortable, unresolved choice. Do older reactors carry more inherent risk than new ones? And is America weighing safety, climate goals, grid reliability, and radioactive waste honestly? Subscribe to follow more investigative stories. As America's nuclear fleet enters uncharted operating territory, Diablo Canyon is no longer just a local hazard or a regional savior. It is a living experiment in risk management. The true test is not whether we can prevent a crisis today, but whether we are prepared to accept the compounding costs of our compromised energy future.